Okay, this is day 4 of Unit 9 transformations. Today we're going to be talking about rotations. And a rotation is a transformation in which a figure is turned about a fixed point. The fixed point is the center of rotation. The number of degrees a figure rotates is the angle of rotation. Rotations are isometries. Now remember, isometries, they preserve distance, so the side lengths are still the same, and it also preserves angle measures so that the angle measures are still the same. So the image and the pre-image are going to be the same size figure. Okay, so looking at this right here, okay, so this right here, WUV, triangle WUV, is the pre-image, and triangle W prime, U prime, V prime is the image. Okay, so the pre-image V and its image V prime are equidistant from the center of rotation. They are equidistant from the center of rotation. Okay, another thing that I have written in these notes right here is when a figure is rotated 90 degrees, 180 degrees, 270 degrees, or 360 degrees about the origin in a coordinate plane, you can use these rules that are down here. Y'all, these rules, you don't have to memorize them. Here's all you have to remember. Looking over here on the left, what I've drawn over here on this graph. Okay, so we know that this right here is quadrant 1. And we know that this right here is quadrant 2. This is quadrant 3. And this is quadrant 4. It just goes counterclockwise, starting right here in the upper right corner. Okay, so the signs for X and Y when you're in quadrant 1, if you're plotting a point up here, the X is positive and the Y is positive. If you're plotting a point and it's in quadrant 2, because you have to go to the left and up, your X coordinate is negative and your Y coordinate is positive. Okay, when you're plotting a point that's in quadrant 3, you go to the left and down, meaning your X is negative and your Y coordinate is also negative. If you're plotting a point that is in quadrant 4, it means you go to the right and down. So that means that your X coordinate is positive and your Y coordinate is negative. This is all y'all need to remember. All right, every time you move a 90 degrees, you're going to go from one quadrant to the next. So if I'm in quadrant 1 and I move 90 degrees counterclockwise, which unless otherwise stated, all the rotations that we do are going to be counterclockwise, which is the opposite direction in which a clock turns. Okay, so if I'm in quadrant 1 and I rotate 90 degrees, I'm going to end up in quadrant 2. And the signs are going to be negative. My X is going to be negative and my Y is going to be positive. Now my X and Y values will switch. So like, for example, if I was at point 3,4 in quadrant 1, I'm now going to be at point -4, +3 in quadrant 2. Okay, so if I'm still in quadrant 1, let's go back there. All right, and let's say I rotate 180 degrees. Well, then I'm just going to go 2 quadrants over because 180 is basically 90 and 90. So I'm going to go quadrant 1, quadrant 2, quadrant 3. Okay, so if I'm in quadrant 1 and I rotate 180 degrees, I will end up in quadrant 3. The X and Y values do not switch here, but you need to pay attention to your signs. Okay, let's go back to quadrant 1. If I'm in quadrant 1 and I'm rotating 270 degrees, that's 90 degrees 3 times. I'm going to end up in quadrant 4. I'm going to go 1, 2, 3. The signs for X and Y are going to be positive and negative. And when you rotate 270 degrees, your X's and Y's values are going to switch again. Okay, so, and then let's go back to, I'll use another example. Again, if I'm at point 3,4 in quadrant 1 and I want to rotate it 270 degrees, I'm going to go 1, 2, 3. I'll be over here in quadrant 4, and I now will be at +4, -3. So when you rotate 90 degrees or 270 degrees, your X and Y values are just going to switch. And we'll look at examples of that in a minute, just so you can see it written down too. Okay, so let's look at the GeoGebra rotations. Let's see if I can get that to work. Here we go. Okay, so basically, when you do a rotation about the origin. Okay, we're going to rotate counterclockwise. Okay, if I am in the second quadrant, it doesn't matter what quadrant you're in. If you rotate 90 degrees, you're going to end up in the next quadrant. Okay, so if I rotate 90 degrees, I'm going to end up in quadrant 3 right here. All right, going back to where we were. If I rotate 180 degrees, I'm going to end up in, from right here, I'm going to end up in quadrant 4 because 180 is 92 times. So I'd have to move 2 quadrants. So let's see what that looks like. So here I am at 180. I'm right here. Okay. And then if I rotate 270 degrees, I'm going to be doing 90 degrees 3 times. That means I'm going to move 3 quadrants. So I'll move 1, 2, 3. I'll be in quadrant 1. So let's see what that looks like. So you're over here at 270 degrees right there. Okay. So now let's look at what it looks like to rotate 360 degrees. That is obviously an entire circle, so you're just going to end up right back where you started, but let's look at what it looks like. So here we go, right at 360, you come right back to where you were. Now let's talk about what we were talking about before. All right, you see where point A right here is at -6, +2. If I rotate 90 degrees, I'm going to be down here. I'm going to be in quadrant 3. But this was -6, +2. So my signs are going to change because I'm changing quadrants. But because I'm rotating 90 degrees, my x and y are also going to change. So right here, my x was 6. So now my y will be 6. And right here, my y was 2. So now my x will be 2. Let's make sure that's where we are. So if we go 90 degrees, right on 90. Okay. So A, which was at -6, +2. A right here is now at -2, -6. Okay, so we had to have a negative and a negative because we are in quadrant 3. But the values, the 2 and the 6, that's what had to change. That also happens when you rotate 270 degrees as well. All right, A right here, all right, is at 2, 6. You're in quadrant 1, so both the signs are positive. Remember over here, you were at -6, 2. So all you had to do is flip-flop the x and the y coordinate. Okay, let's go back to the notes. Okay, so looking at this example right here, it says graph the given rotations. We need to rotate PQRS 90 degrees about the origin. And so P is at 1, 1, Q is at 3, 3, R is at 4, 1, and S is at 3, 0. All right, let's take a minute just to plot these points right here, P, Q, R, and S. Pause the video and draw those points for me. Okay, so after you have your pre-image drawn, all you have to do is rotate this 90 degrees about the origin. I'm just going to go in order and start with point P. Point P is at 1, 1, which is in quadrant 1. Now remember, when you're rotating 90 degrees, you're just going to go to the next quadrant. So P is in quadrant 1, so now it's going to be in quadrant 2. All right, remember the signs for quadrant 2 are -x and a +y. And your x and y values are going to switch. Well, these are just 1, 1, so that kind of makes it easy. So it's just going to be -1, +1. Okay, now I'm going to look at Q. All right, Q is at 3, 3. It's in quadrant 1, so it's just going to go to the next quadrant, which is 2. Okay, and it's going to be a negative and a positive because you're going to be over here. So, and the x and y values switch, but this is just 3, 3. So you're going to be at -3, +3. Okay, so this was P prime, and this was Q prime. Okay, so the next one I'm going to do is point R. R was at 4, 1, which is in quadrant 1. So it's rotating 90 degrees. It is just going to be in next quadrant, which is quadrant 2. Now here, X was 4 and Y is 1. So those are going to switch. So now X will be 1 and Y will be 4. Okay, so you're going to be at 1, 4. Okay, so you're going to, okay, so that will be R prime. Okay, so now let's look at S. S is on the x-axis, so a 90-degree rotation is just going to take it up to the y-axis. Okay, so you still are going to switch your x and y value here. Okay, so S prime is going to be at 0, 3. Okay, so I'm just going to make these lines here real quick. Just draw it in. Whoops. That needs to be green. Okay, so now we have Q, P prime, Q prime, R prime, S prime. There is our rotation image. Okay, pause the video for a moment and you can do number 2. Okay, so we have our pre-image drawn here, right? So we need to rotate it 270 degrees about the origin. Remember, you're going to move 3 quadrants because it's 90 degrees 3 times. You're going to move 3 quadrants around from the quadrant you're currently in. And because we're moving 270 degrees, the x and the y values, they do flip. Okay, so let's start with point F. All right, you're in the second quadrant here at -3, 2. So what you're going to do is you're going to rotate 3 quadrants. So 1, 2, 3, which puts you in quadrant 1 where all the signs are going to be positive. Okay, so I'm just going to write down what F prime is going to be. Okay, so we just said that both signs are going to be positive, but the x and the y flip. So right here, y was 2 and x was -3. So now your F prime is going to be +2, +3. And remember, you look at the signs of the quadrant you're in to determine what the signs of your point are. Right, so I'm going to go ahead and plot F prime, which is at 2, 1, 2, 3. It's right here. Okay, so let's look at G. Point G is in quadrant 3. Okay, again, you're rotating 270 degrees, so that's 90 degrees 3 times. You're going to move 3 quadrants. So you're going to end up in quadrant 1, 2, 3. You're going to end up over here in quadrant 2. And in quadrant 2, your signs are going to be a negative and a positive. And you're going to flip your x and y. Okay, so your x was 3, y was 1. So now G prime is going to be -1, +3. And again, the signs are this way because of the quadrant you're in. You're in quadrant 2. So to plot a point in quadrant 2, you have to go to the left and up, which means it's going to be a -x and a +y. Okay, so I'm going to go ahead and plot G prime, which is at -1, 1, 2, 3 right here. Okay, so here is G prime. All right, H prime. H is in the third quadrant. You're going to rotate 3 quadrants. So 1, 2, 3. You're over here in quadrant 2. Again, your signs are going to be a negative and a positive because to plot in quadrant 2, you have to go to the left and up, meaning that your signs are going to be a negative and then a positive. Okay, so H was at 1, had the values of 1 and 1. So your value here is going to be -1, +1. The signs just retaining what they are in that quadrant. Okay, so -1, +1, you're right here. That's H prime. Okay, so now we have I. I is on the axis right here. You're going to move 90 degrees, though, 3 different times to get to 270, the same way you did any of them. So you'll just be going from axis to axis. So your pre-image here is going to go to this axis here, and that one time. Second time it's going to go here. Third time it's going to go here. Okay, so you end up on the y-axis, sorry, the x-axis, my bad, at point 1, 0. You still have to switch your points because up here your pre-image was at 0, 1, so now you're going to be at 1, 0. Okay, so I'm just going to write that down first. So I prime is going to be at 0, 1, and then let me come write this down. Oops, I wrote that wrong. I'm sorry. It should be 1, 0. I didn't think that sounded right. Okay, so let me erase this real quick right here. All right, so I prime will be at 1, 0. Okay, so 1, 0 right there. Okay, all right, so now we're just going to draw it in. Okay, so there is our rotation. Okay, so some things that I want you to make sure that you remember, I've written down here. So you can pause the video and make sure you have these written down. But you need to know that a 90-degree rotation from the current quadrant will get you to the next quadrant. Remember, 180-degree rotation is just 2 90-degree rotations, so you move 2 quadrants. A 270-degree rotation is just 93 times, so you're going to move 3 quadrants. And 360 degrees is a 90-degree rotation 4 times, so you move 4 quadrants, really, but you just end up back in the same spot because it's a complete circle. All right, think about what quadrant you land in, because the signs of X and Y, or whatever quadrant you're gonna be in, that's how you're gonna know what your signs for X and Y are. Okay, and the X values switch only on 90-degree and 270-degree rotations. They stay the same on 180 degrees and 360 degrees. Okay, only thing you have to look at or what your positive negative values are for X and Y, and that's going to depend on what quadrant you land in. Okay, so pause the video and get these written down, and then we'll move on. Okay, a figure in the plane has rotational symmetry if the figure can be mapped onto itself by a rotation of 180 degrees or less. Okay, so looking at this example of a square, the first one here, it's got 0-degree rotation. I haven't done anything to it. I have this side red so we know how we're turning it. All right, so the center of rotation here is just the center of the square. So then we turn it 45 degrees. It doesn't look like it did in the beginning, so it does not have rotational symmetry of 45 degrees. But when we turn it a complete 90 degrees, it does look like it did in the beginning, okay? So it has rotational symmetry of 90 degrees because it maps onto itself by a rotation of 90 degrees. Okay, so what about a rotation of 180 degrees? Would it have rotational symmetry of that? And what would that look like? Where would this red line be? It would be at the bottom. Okay, so it would look just like this. So a square has rotational symmetry clockwise and counterclockwise of 90 degrees and 180 degrees. So remember, a figure has rotational symmetry if you can turn it up to 180 degrees and it looks just like it did in the beginning. You can't turn it more than 180 degrees. You can just turn it up to 180 degrees. Okay, so let's look at some of these down here. Okay, so looking at these 3, it says which figures have rotational symmetry. For those that do, describe the rotations that map the figure onto itself. So looking at a regular octagon, and remember a regular polygon just means all the sides and angles are congruent. Okay, so I want y'all to take a moment, pause the video, and look to see if you think this has rotational symmetry, and then we'll talk about how to describe it. Okay, so yes, this octagon does have rotational symmetry. If I turned it one way this way, it would have rotational symmetry, and if I turned it, let me delete this, and then if I turned it again, it would have it right here. It would look the same thing, and again, if I turned it here and again here. So it has rotational symmetry of 45 degrees, 90 degrees, 135 degrees, and 180 degrees. Okay? All right, so I want y'all to pause the video and answer numbers 2 and 3 for me. Okay, the parallelogram does have rotational symmetry. It can be mapped onto itself by a clockwise or counterclockwise rotation of 180 degrees about its center. Okay, so basically all you can do is turn this upside down. You can't do 90 degrees with it because then it would be too long this way. All right, if you turned it 45 degrees, it would just be kind of going wonky this way. All right, so the only way you can turn it to look like it did in the beginning is completely upside down, which is 180 degrees. All right, the trapezoid does not have rotational symmetry because there's no way that you could turn it and it would look exactly like it does right now. Okay, so let's look at the next part. Right, so what I want to do is I want to name the coordinates of the vertices of the image after a counterclockwise rotation of the given number of degrees about the origin. So I gave y'all the pre-image. So like in number 1, this is JKLM. And what I want to do is I want to take that and I want to rotate it 90 degrees counterclockwise about the origin. Okay, so pause the video. We've done this already. So pause the video and try to work this one by yourself. Okay, so you have your original here at JKLM, and all you have to do to rotate it 90 degrees is move it to the next quadrant. So we'll just do this in order. So looking at point J is in quadrant 2, so it's just going to move to quadrant 3. Now remember, because we're rotating 90 degrees, our X and Y values are going to switch, but the signs of your X and Y coordinates are going to depend on what quadrant you're in. Because we're going to be in quadrant 3, everything's going to be negative. So you went from quadrant 3, I'm sorry, you went from quadrant 2 to quadrant 3. So J is going to be down here, and it's going to be at -1, -2. I'll get it drawn in a minute. There we go. Okay. All right, so that is J prime. All right, so looking at K is also in quadrant 2. So it is going to move down to quadrant 3. It was at -1, 4, so now we'll be at 4, 1, but because it's in a third quadrant, everything's negative, so it'll be -4, -1. Okay, so there's K prime. Okay, looking at L. L is in quadrant 1. It's rotating 90 degrees. It's going to go to quadrant 2. Okay, it's at 3, 4, so you're just going to flip those. So now you'll be at 4, 3. But the coordinate in quadrant 2 is going to be negative and a positive, so it's going to be -4, +3. So that is L prime right there. Okay, now M is at 3, 1. It's in quadrant 1, so it's going to move to quadrant 2. And the X and Y values are going to flip, so it's going to be at 1, 3. But because it's in quadrant 2, it's going to be a negative and a positive. So it's going to be -1, +3. And that's going to be right there. Okay, so now I'm just going to draw it in. Make sure you also draw it in. There we go. Okay, so y'all go ahead and pause the video and work number 2, and then we'll talk about that one as well. Okay, now you're going to rotate the PQRS 180 degrees about the origin. Okay, so the thing is with this, remember, you're not going to switch the X and Y values. They're going to stay in the same order, but you do need to pay attention to what quadrant you're in so that you know what the signs for your coordinate are. Now you're going to be rotating 180 degrees, so that's like 92 times. You're going to be moving 2 quadrants. So we'll start with P. We're in quadrant 1 here, so we're going to move 2 quadrants. We'll move 1, 2. So we end up down here in the third quadrant. All right, in the third quadrant down here, all the signs are negative. So you're going to be at -1, -3. So draw that at -1, -3 is right here. Okay. All right. So we have that one. That's P prime. Okay. So Q is also in quadrant 1, and it's going to move 2 quadrants because it's got to rotate 180 degrees. So we're going to be down here, 1, 2, also in quadrant 3. So you were at 3, 5. Now you're going to be at -3, -5. So 1, 2, 3, 1, 2, 3, 4, 5. Okay. Now R, which is also in quadrant 1, will be moving also 2 quadrants. So you go from quadrant 1, 2, quadrant 3. Okay. So, and your X and Y coordinates stay in the same order, but your signs are going to change. So now you'll be at -4, -2. This is R prime. Okay. So S. S is on the x-axis here. It's at 2, 0. All right, so to move it 2 times, just go to the axes twice. So 1, 2. And it's going to stay the same order of the xy coordinates as it already is. So you're at 2, 0. Sorry, negative 2, 0, which will be right here. Okay, so now you just have to connect the dots and make sure you also connect the dots. I didn't do such a good job right there, but that's okay. Okay, so that wraps up this lesson for day 4, rotations. The next lesson is going to be on the compositions of isometries, which will complete our transformations. So I'll catch you on the next video.